row operations are a huge piece of matrices. They're what we're allowed to do to a matrix in order to keep it equal when we have it related to an equation. So it's very similar to what we can do with an equation. For example, we can multiply an entire row by a scalar number, similar to like we do when we solve equations. Or like when we do with elimination, we can multiply a row by a scalar and then add it to another row, like we're adding equations. So these are just a couple examples of row operations. This first one, notice it says 1/2 times row 1. So what that means is we're going to rewrite the matrix. Notice it's 1/2 times row 1. That means rows 2 and 3 are going to stay exactly the same. So when we're doing row operations, we always only replace one row at a time. Well, in this case, the only row we're doing anything with is row 1, so that's what we're going to replace. And if we do 1/2 times row 1, or 1/2 times 2 is 1. 1/2 times 15 would be 7.5. Or you could write that in as 15 halves. And that's it. It's just the idea you can multiply an entire row by a scalar number, and you still have an equivalent matrix. This second one is the piece that can get a little more confusing, but it will be imperative that we know how to use it. So this is where it says we're going to multiply row 3 by -5, and then we're going to add it to row 1. Whatever our second row here is, that's the row we're replacing. So we aren't actually going to replace row 3 here. Similar to when we do elimination, we multiply equations by a scalar so that we can get rid of a variable. So let's go ahead and write out our matrix. Again, row 1 is the only one we're changing. And generally, whenever I write my rules out like this, it's always that second row that is going to be my circle. So rows 2 and 3 stay the same. So now to get those top 3 spots, we're going to do -5 times row 3. So in this case, that would be -40. And then I'm going to add it to row 1. So -40 plus 2 is -38. Same for the second spot. So -5 times row 3. So -5 times 3 is -15. Add it to 15. Those cancel out, and we get 0. So we don't actually have to write this in the end. That was just my work to help me get there. And the reason we do this is this idea of being able to get a 0 to cancel numbers out. So we will use this multiplying and adding to rows in order to get zeros in matrices. Same idea as elimination. We're trying to eliminate an element of the matrix. So in summary, starting with A, we multiply rows in order to get elements to be number 1. So multiply rows to turn an element into 1. And then we do this add rows, so we add multiples of rows in order to turn elements to 0.